Okay, so this is our presentation for our Epic Cool Box. It is me and Shazil working on this project. So our team name is the Underdogs, and here we go.
Yeah, so for the problem statement, it's basically the reason why you're basically making a project. So in our case, the problem statement was basically the DIY project. It has to be a moving part, and it has to be, more importantly, you shouldn't be touching a box. So it's basically an automatic box with at least one moving part, in our case, which is a lid. And it should be a small, affordable, and time efficient.
This is the table of our objectives, constraints, and metrics. On the right side or on the left side, we have our objectives and constraints, and there is supposed to be an O and C for the left side, but basically, to put it simply, the first four, lightweight, time efficient, small, and affordable, are all O's. So they're the objectives, and our constraints are the last five, which is the box has to be able to operate without human interaction. It has to use at least one or two moving parts. The lid must open via an electric device. It has to be safe to use, and it has to be made of in-class materials, that being our Arduino kit that we have received from the campus. And then on the right side is our metrics. So the metrics are based off of what the objectives and constraints are. So lightweight, it's the box is being measured in ounces. Time efficiency in seconds, and so on and so forth.
Yeah, for the morph chart, morphology chart, it's basically helps you understand or basically gets you the main wider idea for the project. So, for example, like you'll be writing more. So it's basically more towards the efficient of the time management and basically optimizing the resources.
Yeah. And here is our final morph chart. It started out with about, I'd say, our first morph chart that we made. We had about 115,000 different
Yeah.
possible outcomes. And we narrowed it down to 96. And from those 96 concepts, we came up with our final two. So we broke down to five, then we broke down to two. And our top two concepts, I'm going to move this.
So for the top two concepts, we basically selected concept number two. It was basically really simple if we compared with the other ones. So basically, our concept basically had a cardboard box, Arduino UNO R3, a motion sensor, powered LED, and a duct tape, which was pretty simple. And as you can see from the concept number six, we have a plastic Arduino R3 ultrasonic sensor, which was basically working example other than the motion sensor. And we have a battery and the other, for example, a scotch tape.
Our top two concepts, we, in order to narrow it down to our to concept number two, we used a best of class table and scored each objective out of 10. And if it matches up, or whichever concept has the highest score, concept one is supposed to say concept two. Oh, yeah, concept one has to say concept two, and concept two is supposed to say concept six. But I messed up there. That's my fault. Concept two managed to outscore concept six. So concept two was for a score of lightweight, it scored 7. Time efficiency, score of 10. Small, 8, because the box is pretty small, and that kind of plays in part with a lightweight. Affordable, 10. Concept 6 would have required us to buy a plastic box, because I don't think either of us would use a household item and kind of ruin it for a box. So simply put, concept 2 is our top concept.
So basically, we decided concept number 2, as mentioned by Alkandros, that all of our concepts has some, either it has to be like using a lot more materials, or in our case for the concept 2 was a winner. So we were using Arduino R3, a motion sensor, a USB cable to attach with your, either with your laptop or something, LED light, a servo motor to basically control the arms, how the lid works, a duct tape to hold the box together, a cardboard to basically the entire material of the box which is made. So we decided concept 2 as our final PC.
Yeah. And concept 2 of a Arduino Uno R3, a motion sensor, a USB cable to get the coding, and a LED, a servo motor, duct tape, and cardboard for the box. And here's a drawing of our final design, which is concept 2. It may look a little confusing, but the lid is supposed to be that top part up there. Yeah. It's supposed to be the top part. It's supposed to be longer, not pressed together, but that's an error on our part. But yeah.
So here's the CAD model. So we have basically made 2 of them, and it's basically the same thing, but the depth, which we not able to do that. Okay, so it basically has the same thing, and the arms, so it has like a mechanical part through which the box opens, and we have like all of the components, which is mentioned in the previous slide, which is a 9. Yeah, that's basically all